Hello everyone, a very good afternoon. I hope everyone is safe, everyone is keeping well with their health and otherwise. So this is the fourth part of the tutorial series where we are trying to understand how we can create a custom data generator or a data loader to train different deep learning models. And in this fourth part, we'll be creating a data loader to train a video classifier where we'll see how we can load sequence of input. And in this example, we'll be loading video data. So let's get started. Let's see how we can do that. So in the first initial video, we already discussed what a generator function is in Python. So if you want a refresher, you can just quickly go and have a look at that. And in the previous video, we wrote a generator function for training an image classifier where we are able to create a data loader to load and feed image data. And in this video, we are going to do that for a sequence of input and that will be video for us. So we have already covered how we can, load image and train a network. This video will be looking into the sequence of input or training a video classifier with a 3D CNN. And in the next video, we'll see if we have ensemble of model like a image and a video, then how we can create data loader for feeding different kinds of inputs. Okay. So just a quick revision for how we basically create a data loader for an image classifier. It's very simple. So you have your data. First of all, we create a CSV file, and that CSV file will be having all the file names and its corresponding labels, which will be feeding to prepare our data generator. And the basic idea is that we should prepare our sample in this format, in this tuple format, where we have one sample which consists of a file name and its corresponding label, and we have such list of samples. So this is the basic or a template that we can use for creating any data generator. So for example, if it's an image, your data loader, it should be giving you, image and its corresponding label. So when you prepare the samples, it should be in this format itself. Like you have a file name for the image and its corresponding label, that becomes one sample, and the next is a file name and its label, that's become the another sample, and so on. And if we have a video input, then one sample will not have just one file name. It will have frame 1 file name, frame 2 file name, and then its corresponding label. So basically, this is one video. So one sample will have one video and its corresponding label. Next sample will have another video consisting of, several frames and another label. So we have to create in this format, and then once we prepare our samples in this format, we can easily read it, and then the data generator can then serve it to the model to train. So we'll see how this thing works. So for this example, I'm going to train a action recognition classifier with 3D CNN, and the video dataset that we'll be using is from the UCF 101 action recognition dataset. The link will be provided. But here again, the idea is to show you how to create a custom data generator for your own data. So I will not be taking their label format. I'll be just taking three of the data classes from the UCF 101 action recognition dataset, the archery, basketball, and biking. And with this three activity, we will see how we can prepare our data loader. Okay. So also I have made a video already if how you can collect your own data. So if you have a camera and you want to record and save live data, suppose you want to make your own, own video data for action classification. So there is a video which I've done it. If you want, you can, go and have a look at it, how to prepare your own video data. Or yeah, so okay, so in order to prepare the data set, we have to follow a few sequence of steps, but again, it may be confusing if you see as a whole, but if you go step by step, it's very, very simple, yeah. So first of all, what we have to do, suppose if you have a video data set, which you have collected, or for our case, it's from the three videos from the UCF 101 data set. So if you have a separate train and test, well and good. If not, what I have done here is I have prepared own train and test where 80% of the videos in each category I have kept in the train section, and 20% I have taken in the test section. Now, this video is in the video format like .avi or .mp4. What I have to do is now we have to convert this video into frames and save each of the frame as an image frame. and this will help us to easily load the data when we're preparing the data loader. uh, because with that we can create the CSV file, and from the CSV file we can directly load frame by frame. And also in many dataset you would see that uh, many dataset are saved in this format as well. Some are in saved in video format, and many you'll find they're saved in this frame by frame format. And we'll create a new directory called activity data where all the videos uh, will be saved as frames, and this will be a working directory. And then we'll use this to prepare our labeled CSV file like the way we did in image classifier. Now again I'll show you everything what I'm meaning by it. So as of now your dataset would be looking in this format. So this is UCF train archery, where there is video in the AVI format. What we have to do is for every video we have to create a folder like V archery G01 C01 V archery G01 C02, and inside every folder there is frame corresponding to that specific video. So this is the first video, and these are the frames from the first video. Okay, and we will have such folders for every video. So basically what we're doing, we're taking this video and we are saving it as a frame. Okay, that's the idea. So this is the step one. So you will have the data set in this format. So UCF101 train. Inside train you have archery category, and inside archery we have this the video. Then we have basketball, and we have video and biking, and then similarly for the test. So what we'll do in the first step, from this UCF we'll create a new hierarchical data structure, which is will be activity data. It will have train and test. Inside train like this only, there will be this archery, and inside archery for every video there is a folder in the name of that video, and inside that folder there will be the images like image 001 002 and so on. And this will be doing for every video, there will be directory, and then for every category the same thing will be repeated. Okay, and yeah, this is step one. So let's go through the code of how we can do this. Okay. So I'll not be running the code here because it will take a lot of time because there are many videos, but I'll walk you through the code, and this code will also be uploaded at my GitHub, and all the links I'll provide in the description. So let's get through it. So you can see I'm just importing the libraries, and then I have the root directory for my original data set, which is UCF101. Then that's my destination directory, activity data. And if the directory is not there, then this command will create it. Now what I'm going to do is I'm going to list whatever directory is there in this root directory. So we have basically two directory, train and test, and inside train we have archery, basketball, biking, and inside test again we have archery, basketball, biking. Now this is the function which converts these videos to frame, and this is the function which we'll use to write those converted frames to a PNG file format and save it. So let's walk through it. So what we are going to do is for data directory in data directory list. So the basic idea is that we'll read both train and test directory one by one. So first we'll read the train directory. And what we are going to do is we are going to create a source path or data path. So now the path will be UCF101 train. And then we have a destination path where we want to save it. And destination path will be say activity data train. And if that's not there, again, we'll create it. And then we are going to read all the three activities inside the train directory. So this activity list will have this three folder: archery, basketball, and biking. And now for each of the activity, archery, basketball, biking, we are going to read the videos present there. Okay, so we'll loop over every activity folder. So for the first case it's archery, and now the path of that activity would be UCF101 train archery, and destination path would become activity data train archery. And again, if this archery is not there, it will be created. And then we'll call this write frame function, which will pass the source activity path, this one, and the destination activity path, and it will be reading these videos from the source path and writing it as a frame in the destination path. Okay, so what we are going to do, we are going to list all the videos present in the archery folder. So the videos are say C01.avi, C02.avi, and so on, all the videos. So it will loop over and read one by one. So for example, when you start looping, the first video will be the C01.avi, and we'll keep the folder name as the name of the video. We'll just get rid of this .avi, and that will be our destination directory. And then our destination path would become again activity data train archery and the name of this video. And then this is the source path of the video, archery c01.avi, and then we'll initialize a cap object uh, to read this video. Now once we read this video, we'll loop over all the frames, and then we'll create a output file name, which would be say image 001.png, and the output frame path would be again in this destination folder as a frame image 001, and in the next read it will be 002, and so on. And this will become your output path, the destination folder path and the file name. And what we'll do, we'll simply then, okay, just a second, yeah, we will simply do a im show for every frame, and at the same time we'll be writing it. And once the number of frames in that video finishes, there I have put that in a try except block, and then that cap is released. Okay, and this we are going to do it, this was only for one video, this we are going to do it for every video. Okay, and once archery this is complete, then we are going to loop over again here and read the next, which is the basketball, and so on. Okay, and in this way you'll be able to do the first step. So I'll just show you how it will look like in your directory. So this is UCF 101, this was the train and test, and it has three folder in every train test category, and inside that there are videos. Okay, 01, 02 AVI, 05 AVI, and on also on. And then maybe I'll just open a simultaneous uh, folder just to show you. Okay, custom data generator. Yeah, if you can see here, now this is your this was your UCF. Now I have created a folder activity data, and inside train, sorry, okay, it's here, sorry. Yeah, so we have created activity data, and inside train we have archery, and inside archery we'll have this folder corresponding to each video, and inside every folder we have now frames from each video. Okay, so this is the first step, and this piece of code which we just discussed will do that. Okay, no big issue. So we are done with the first step. Now let's move to the second step. So now our working directory would look like this. We have activity data. Inside that we have train. We have every class, archery, basketball, biking. And for every class we have videos. And for every video directory we have the corresponding frames for that video. Now we have to create a corresponding CSV file for each of those videos. So this is the video one. So we'll have a CSV file for that. This is video 2, we'll have a CSV file for that, and so on. And now this, what this CSV file will contain simply is each of the CSV file will contain the path of the frame of that video. For example, the first video, which is the first video CSV, it will have the path like activity data train archery, the video name directory, and the image, say 001, 001, 002, 003, and so on. And we will have corresponding labels for every frame. So it's the same way the way we did it for image, but we are preparing it here because in videos we'll be loading sequence of frames, and we can read from here itself. Suppose if you want to read 10 frames, then we can read this video CSV file and load from 1 to 10 directly. So this will help us in doing that. And let's see in Jupyter Notebook example how we can prepare the CSV file from your data folder. Okay, so at this step right now, we have this data structure. We have our activity data. Inside that we have train, we have archery, we have folders, and inside every folder we have the frame names. Now let's write a CSV file for the path of every frame name. Okay, so let's get started. So first, I'm importing the required library, which right now here we just need a OS module and the pandas PD to do some data manipulation. So our root data directory is activity data, it's fine. And our number of classes, there are three number of classes, and I'm creating a dictionary to map the class name with the labels. So archery will be 0, basketball would be 1, and biking would be 2. Then I have two data path. One is for the train and one is for the test. So activity data train, activity data test. And yeah, okay, so we'll create it from scratch. So I have already done it with the name data files underscore 2. So let's do from scratch. So I'll just rename it as data files. And this is hard coded here, but you can just use a variable so that you don't have to change everything again, but it's fine. Okay, so if this segment, what will do if this data files is not there, or data files slash train or slash test is not there, it will create it. So when we run this, we'll see a data files folder will be created for us with train and test, and now it's all empty. So next, what we'll do is okay, it's here. So we'll read the the content of the train data path, and here in our case, it's just three activity. Now, what we are going to do, this is the code segment to write the path of every image frame in the CSV file. So here we have three loops. Okay, the first loop will loop over every activity like archery, basketball, biking. The second loop is going to loop over every video within an activity. So within archery, whatever videos are there, it will loop over that. And then the third loop is to loop over all the frames within one video. So archery can have 100 videos, and for every video we'll have so many frames, and this loop is going to this for loop is going to loop over every frame. Okay, so the first, when we run this one, it will be selecting the archery, and then we'll list out all the folders within the archery directory, which will be all the videos. And now for every videos, what we are going to do, because for every video we are having one CSV file to store the frame names along with their labels. So for every video file, we are going to create one data frame. Now data frame will have three columns: the file name, the label, and the class name. Okay, now we are going to within within that video, we are going to list out all the images. Now for every image, we are going to loop over it, and for every image we are going to define one full path. So it will have this train data path, which is activity slash train, then data directory, which is your archery, and then the video name, and within that video the image name, which will be say image 001, and then 002, and so on. And then we'll append it to this data frame, train data frame, and then we'll define a file name. Now the file name of the CSV will be the same name as that of the video name, and then we'll write this data frame to the CSV file. Okay, and same thing we are going to do it for the test data. It's the same. So I'll run it here, and it will take some time for us. Let's see if yeah, okay, so you can see already it's creating the CSV file for every video which was there. Okay, and the name of the CSV file will be the name of the video dot CSV, and inside this CSV file you will see this content where it has simply the full path, the file name. See, this is the video image 001, 002, 003, and so far on, and the labels and the classes. Okay, so here okay, so this will do it, and I'll pause for a while. This is done, or we can continue actually. So, and there are two ways, one is I'll just show you here. So one here, what we have done right now is that inside the train, okay, we have created the CSV file for all the videos, okay, archery, basketball, everything. And for every video, there is a separate CSV file. If you want, again, that depends how you want to prepare your dataset. You can also, merge everything in a single CSV file, where instead of having a separate CSV file for your entire for your individual video, you can have one CSV file with all the paths for all the frames in your entire data set, archery, biking, everything in just one CSV file. Again, that like especially in this Coco dataset, I saw there was this kind of format of the data. But for this video, let's assume that our data structure is like this, that inside this folder, we have a single CSV file for a single video. Okay, so let's see if it's done for us. Okay, I think it'll be done. Meanwhile, I'll pause it. So our CSV file preparation is done, and this is the two things that we just need to prepare our custom data generator. One is activity data, where it contains all our video frames, and then this and then this activity data, and then this data files, which has our CSV file having the full path of the frames and their corresponding labels. So with that prepared, let's get to actually how to prepare the data loader. Okay, so let me choose a pointer. I'll use a laser pointer. Okay, so this part is done. Now, before we move down, when we are preparing a video dataset, you have to understand one thing is a video consists of number of frames. So there is one thing that you have to define that's called temporal length. Okay, temporal length means how many frames you want to take as one sample or in order to train it. So for example, if you want to train, this is a scenario where suppose your video has just 7 frames and you took a temporal length of 3 frames, it means that your one sample will just consist of 3 frames. Now, another term is temporal stride. So, temporal stride means from this video of 7 frames, since your temporal length is 3, you can actually create many samples. While you're creating those samples, how many of frames you want to leave and go. So, for example, this is a let's take this example. So, there are total images of 7, and our temporal length is 3, and let's consider our temporal stride is 1. So our samples could consist of first sample would be 1, 2, 3 frame. Second sample, because stride of 1 will be just leaving 1 frame, and second sample would be frames 2, 3, 4, and the third will be 3, 4, 5, and then 4, 5, 6, and 5, 6, 7. What if your temporal stride is 2? It means when we are choosing the next sample, we'll be leaving 2 frames gap. Okay, so for example, the first sample would be 1, 2, 3, and the next sample would not start from 2, it will start from 3. It will be 3, 4, 5, and then the next sample would start from 5 rather than going from the next, and it will be 5, 6, 7. So as you can see, there are two parameters that you can vary while preparing your data loader for loading the videos. One is the temporal length, number of frames from that video you want to load as one sample. 3, 4, 15, 16. Usually, in many paper they use 16 frames for one sample. And another is the temporal stride. So how many strides you want to follow in order to take the next sample from the same video. So there's also a way that suppose if you want to take just one sample from one video, then you do not use the stride option and take multiple sample from that video. Suppose your temporal length is 3, just choose at a specific offset, just choose 3 frames from a video, and you can get one sample from one video. But assuming that we'll be getting many samples from a single video, we can follow this. And if we generalize with a formula for getting the number of samples that we can get from one video, then we can write like this: number of total images in that video, number of total image frame, minus the temporal length, at what temporal length you want to use as one sample, divided by the temporal stride plus 1. So in the first example, when we took this with a stride of 1 and a temporal length of 3, you will get 5 samples. As you can see, 1, 2, 3, 4, 5. And if a temporal stride of 2 was used, then you would have gotten 3 samples, as you can get from the formula. And here also, 1, 2, 3 is one sample, 3, 4, 5 is another, 5, 6, 7 is another. So I just wanted to explain this before we go and execute the code, that how I have written this data loader using this structure. Okay, so yeah, so basically when we have to write this data generator for video data, you can divide it into 2 steps. So first we'll be loading those sample, and this load sample function, it will load the file names in proper sequence. So usually it's a video, so whenever we ask the data loader or generator, it should give us a video along with its label. Now video will have multiple frames, so our data structure would look like this. Now there will be a list of frames and a corresponding label for one sample. And then the next step is that once we have this loaded sample, we actually read this sample. So actually, yeah, the loaded sample will look like this. I got a bit excited. So this is from the code. So this is the 0th sample with a temporal length of 16. It will be having 16 frame names and one label to that video. And this is the 8900th sample. It will again have 16 frame names and a label of 2. So this is your loaded sample would look something like this, the first step. And the next step, that you take this loaded sample, and whenever the data generator asks as many sample as it want for the training, like suppose if you're using a batch size of 16, then it will give you such 16 or 30, it will give you such 16 or 32 samples. And in the second step, you're actually going to read those frames and put it into a 3-dimensional or 4-dimensional tensor, and then feed it to the data loader, or feed it to the model for training. And you will have, for one such sample, you will have one label like this. Okay, So the first step of loading samples, I have written one function called file generator. So before we go and execute it, I just want to quickly walk through it in the presentation slide. So maybe I'll choose another pointer option, a pen. Is it writing? Yeah. So what I'm doing here right now is I have a data file. So what data files? It's a list of all the CSV files. So this is the list of CSV files in my train directory. This will have it, and it's going to loop over all those CSV files. Okay, the first for loop. And then I'm going to read the labels. Sorry, I'm going to read the CSV file. And as we prepare the CSV file with a column name label to read all the labels, the label list will do that. And then we'll get total number of images from the total number of frames within that CSV file. Now, if your number of images is has to be greater than or equal to temporal length. If your number of frames, for example, you are taking a temporal length of 16 and your number of images is less than 16, then you cannot make any sample. Okay, if that case is justified, then we'll use that formula we discussed to count the total number of samples, and we can print out that how many samples from this video sequence we are going to get. And then we'll prepare a list called image list. So this image list is basically going to contain all these file names from that CSV file. Okay, list of all these file names, right? Now once we have this list of file names from this video, we are going to use this to actually prepare our to load the samples in that proper format, you know, of 16 of one sample containing say a 16 frame name and one label. So for this I'm going to initialize one queue. So assume this is your queue. Now it's going to loop over all the images in the image list, and it's going to append that image name into this queue sample. So for example, the first sample is suppose 1, the frame name is 1, it's enqueued. And then next, again it will again loop, and it will add the second frame name. Then again it will add the third frame name, and it will do so until 16. 16 here is the temporal length as we have defined here. And now this function will check that if length of samples or length of this queue that we have defined is equal to the temporal length, like the 16 here, then what it will do, it will create a copy of this queue, like this one. This is a copy. And then again, this is a counter to count the number of samples. Now after doing this, it will see what is the temporal stride, how many frames we have to leave in order to take the next sample. For our case, it is supposed to. Then it will, from the left of the queue, it will pop out this first two elements. Now you will be left with 3, 4, 5, 6. So there are basically total 14 samples here now. Okay. Next, what you will do, you will return this was your prepared sample. You will return this as one sample along with its label. And next, you will start again filling it up. Again, you are reading the images, and again you get the 17th frame, and the next you get the 18th frame. Now again, it will check if your number of samples is equal to the temporal length, which is 16 in our case. Then again, it will return it as a new sample. So it will, in this way, you'll use this queue, a running this will be a running queue where we can pop left the used frames and append the latest frames, and in this way we can prepare the samples. Okay, so this queue will be helping us this to create samples in this format. So first sample 1 will be having 16 frame name and its label. Then the second will be from because of stride of true 3 to 18. Then the third will be 5 to 20, and so on. We'll do it till this number of images in this image list gets exhausted, and then we'll read over the next CSV file, and we are going to repeat the same. Now that was the first step of loading samples. Now the next step is, once we have loaded the samples and you actually want to train your network, then you will create this data generator using this loaded sample, which has a format of this, the frame name, 16 frame name and its label. And then we'll actually use say some image processing library like OpenCV or PIL, and read those samples from this, like the 16 frames and its label, and then we can feed it for training. Now again, that depends on your batch size. If you use a batch size of 3, then 3 samples will be loaded at once, and so on. So this is it, and yeah, let's directly go to the notebook and execute the code and see how it's happening. Once we have understood the theoretical part of it, now let's directly implement it in this notebook. So we'll simply import all the necessary libraries, and this is the helper function that we discussed just now in the PPT. So this is the helper function to take the list of data files and then yield the sample. Again, this itself is also a data generate. It's a generator function, which is instead of giving out all the samples prepared as a one simple list, it is giving you as an on when you request it. So we'll wrap this over a load function. So we'll just run it. So this is the load sample function. And here what we are going to do is we are going to pass, say if you want to load the train samples or test samples, you can pass it here. Then we'll pass the parameter of temporal stride and the temporal length that we discussed. Then we'll read the data files. Here we are reading the train files, so it will have the data files will have all the CSV files corresponding to the video of the train folder. And then we'll call this wrapper function file generator that we just use, and we'll create an object for this generator function. Now we'll initialize a list called data list, in which we'll be appending all the samples that will be returned one by one by this file generator. So we will start a iterator here, okay? And while this, sorry, uh, um, if I can make, okay, sorry. So while this iterator is true, what we are going to do is we calling this next function and of this generator, this file generator, and this will be giving you sample one by one, and then we'll be converting into a list, and then we'll be appending it in this format where X is one sample and Y is the corresponding label to it. Okay, and once it gets finished, then we'll make the iterator false, and then it will come out of the loop and will return the data list, which will have your list of samples, where every sample will be in this format of the 16 frame file name and one corresponding label. Okay, so this is the load sample function that we are going to call. So I'm first going to load all the train data samples in a proper sequence. So I'm going to pass category of train. A temporal stride I'll be using here is 4 and temporal length 16. And when I run it, you will see that it's reading video sequence one by one, and it's also saying that in that video sequence how many samples we can generate with the logic that we discussed in the PPT. And you will see, for different video samples, it read from basketball, archery, and here are some, you see, some of the videos in which the number of frames is less than 16. So in that case, it's discarding those videos. Now, in case if the temporal length is less than 16, you can also do some kind of temporal padding, where you can just say if append the last frames to make it up to 16. There's a simple logic we can add it, but right now let's just continue with this. Okay, so now when you print this number of train data samples, it says there are 12,277 samples. And let's see what one sample contains. So if you see train data of 0, so one sample as of now, it contains like this. Sorry, again. Yeah, so it's in this format. It has 16 frames, consecutive frames, and one label to it. Okay, this is one sample. And if we run this, where I'm reading the two samples, 5000 to 5002, then you will see there are two samples in it. Yeah, there are two samples where first sample has 16 frames, one label. The second sample is again 16 frames and another label to it. Okay, so we are sure, okay, we have loaded the test data in correct format from the CSV file. Now, similarly, we can also load the test samples. And yeah, once we have, I'll just make it small for a while. Once we have loaded this test sample, next loaded the train and test sample, we have to use this loaded train and test sample to create your actual data generator, which will actually read those samples and return it to be a to be trained for the neural network. So this is consecutively, like you see, the samples are in continuous format because they are read continuously from the continuous frames. So we can use this function to shuffle it. Then we can use some kind of pre-processing, like whether you want to resize those frames, like let me zoom it and resize it or normalize it or whatsoever. Then this is your main data generator function, where we pass the loaded samples, we pass the batch size, the temporal padding, the again I think, have I added temporal padding here? Maybe. Okay, maybe I forgot to discuss it. And then this is shuffling. So basically it's going to yield data in this format. but this will be read. It won't be file name, it will be actually array, and there will be corresponding label. So what we'll do, once we have this sample, we'll be shuffling it, and then we'll start to read one by one. So we'll give a for loop, and okay. hmm Okay, okay, fine. So we have this for loop, and depending on the batch size, it will, suppose if batch size is 10, then it's going to read 10 samples, and in the next it will read from the 11 to 20th. So this offset is used for that. So we'll have 0. So this is the range function, 0 up to number of samples, and at what, like suppose if it's 2, then it will be reading 0 and the next 2 and next 4, like that. So this range function, this batch size will do that. It will give the offset. So you will be reading the data samples from offsets. So 0 to 0 plus batch size 10. In the next side, it will become 10. Then 10 is to 10 plus 10, 20. So 0 to 10, 10 to 20, 20 to 30, and so on. It will read it depending on the batch size. Then we'll have two lists, X train and Y train. Now for each of the batch sample, because in each of the sample we have 16 frames, we are going to read all those 16 frames. So your X, that the frame, will be the batch sample of 0, and your label will be batch sample of 1, because every sample that we prepared is a tuple of the frame names, 16 frame names, and the label. Okay. Now we'll be reading in every of the sample, we'll be reading all those images like cv2.read. We'll do some processing and we'll append it here. And next, whatever this one sample is read, this one sample is loaded into this X train, and then this is converted into an array. Similarly, Y train is converted into an array. And then one more pre-processing that we are doing here is, because we will be using Keras to train it. Again, if you're using PyTorch or something, maybe you not do this. I'm converting these labels into a format of one hot encoding. So again, I'm not going to discuss one-hot encoding here. Suppose if label is 0, then the label will be converted into 100. If it's 1, then 010. If it's 2, then 001. And then it will yield one batch of X train and Y train. So let's run this. It will make more sense. So I'll initialize a generator function with data generator function that we discussed here, and I'm passing the train data, the loaded samples from the train folder. I'm giving a batch size of 4. I'm giving a shuffle of true. Now, when you run this, let's call one of the sample. So when we call with using the next, we can, iterate over the generator function. So you will see that starting index was 0. Again, when we call next, starting index would be 4, and then batch size is what, 4, yeah, then 8, and so on. And you will see the shape of your data is 4 comma 16 comma 224 by 224 by 3. Okay, so here the image size is 224 by 224. There are 3 channels, and there are 16 frames in one sample, and there are 4 such samples. So for one sample, there will be one label. So there are 4 labels, and because it's one hot encoded format, each label will be having, 3. It'll be like this. Sorry, yeah. So each of there are 4 samples. This is one label. This is another label. This is another. So for this one is for bike, because this corresponds to label 2. This corresponds to label 0. Archery label 0. Label 0. Okay. Now let's read one of the samples. Let's visualize one of the samples. Let's take the third sample. And when you print third sample, you will see that the sample size is 16 frame, and each frame is of this size. So the batch had, 4 samples, and each samples were like this. And when we just read one sample, it will be 16 by 224 by 224 by 3. And one of the label, it will have just a three-dimensional this list. Now I have written the labels to class dictionary in one config file that we defined in the beginning, that 0 is archery, 1 is this. So if we want to see which activity this specific label is, then we can see that, okay, this is archery, and then we can read one of the samples. So there are 16 samples. Okay, so if I use this function to plot one of the samples, you will see the plotted sample very soon. Yeah, so this is one of your sample. It has 16 frames, and its label is its activity archery. So this is your data generator function that we have created. So it was very simple, just 3 steps. We have this load sample function, where first of all we load all the CSV files. This loaded CSV files then we pass to our helper file generator, which reads the CSV file one by one, and then it will read the images in those CSV file. And once the temporal length, the 16 say number of frames equal to temporal length is appended to that queue, it will return it as one sample. And we will be using this helper function to load all those samples and store it in this data list. Okay, here. And then we'll use this loaded sample into the generator function. Okay, and how this will be, like, we can also define the batch size here. So depending on the batch size, it will read as many samples from this data list that we just prepared. And then for every batch of samples, suppose there are, here we took a batch size of 10, there will be 10 batches, and for each batch there are 16 frames to read. So it will loop over every batch, and for one of those batches, uh, then it will loop over all those 16 frames and apply any kind of pre-processing, and then it will, append it into temp data list for one batch. And once it has loaded all the batches, it will append it to this X train, convert into an array. And similarly, this label, which is like 0, 1, and 2, we can convert into this one hot encoding for training into Keras model. Again, if we are using any other model, any other say format, or for training in PyTorch where they may not require this kind of one hot encoding, then you need not this step. And then it's going to yield your batch of data and batch of label. Okay, so just as we saw here, when we are calling it, it's reading a shape of 4 by 16 by 224 by 2243. There are 4 samples. Each samples is of shape 16 temporal dimension, 16 frames. Each frame is of length 224 by 224 by 3. Now this notebook is for understanding. Now I have created uh, a Python script, datagen.py, where I have put everything, I've kept everything in class. So there's a class action data generator where I've defined this file generator function, the load sample function, the shuffle data. It's pretty much self-explanatory, and it's the same thing from the notebook, just a bit structured. And you can simply call this data generator function, and you can load this data generator and start training. So let's do this. I will train a model here. I'll stop it as training once. Let me stop this notebook for a while. Yeah. So we'll whatever data generator that we just created and we have wrapped in this class action data generator, we'll call it here and train a Keras model. So I'm going to train a 3D CNN model. So I'll be importing all the convolution 3D layers. So let's import this. Now this is my root data path, the data files where I've stored all the CSV file, and I'm creating an object, data generator object with this action data generator. I'll give the root data path, I'll give the temporal stride, I'll give the temporal length, and the resize option. Okay, and then we'll load the samples first. So using this data generator, we'll load the samples for the train data, we'll load the samples for the test data. We'll do that. And then next, once we have loaded these samples, then we create a train data generator by using this data generator function of that class and passing it the loaded train data samples, the batch size, and then whether we want to shuffle it or not. And similarly, the test generator, again, it's loaded test data samples, batch size, whether we want to shuffle it or not. So let's create it. And this is our model. Again, I'm not going into depth, and also this not might be the best model to train action recognition data, but this video is more of showing you how to create data loaders. So that's why I've just taken any random network, and I have defined it here. This is the model. Now, once our model is defined, okay, then we can start training using this model.fit generator. So here I'm using test generator. Let's use train generator. And steps per epoch, let's give train. And here I'm training for 3 epochs. And once you give this, then it should start training. So epoch 1 of 3, and it starts training. So it means our data generator is working. And previously I was training, it already reached 60% on my CPU based laptop. So I hope you got the idea of how to create this generator function. Although this video was quite long because I wanted to explain you all the nuts and bolts behind this function. But again, if you want to use it for your use it as a base script for your model, you can use this datagen.py. It's within the class, in not struggle much. Just you have to change few options. And one thing that I was talking about, the temporal padding, sorry, which you can integrate it is this way. For example, I have given here, mm, sorry, let's do this and then we'll make it big. So you see, before what we were doing is if the uh, number of images were not equal to temporal length, we were discarding those frames. Here, what we can do is there we'll first calculate how many frames are missing. So temporal length minus the total images. So if temporal length is 16 and number of images is 14, then there are two frames to add. And then we'll simply append the last file name. Okay. So for example, the 14th frame will append the same in the 15th and in the 16th frame. So in this way, that video will have 16 frames, and you can use that. So this is one kind of temporal padding where we just append the same. You could use any different kind of temporal padding. But again, I'll upload this notebook as well, and I really don't want to make this video, although it's already long. But yeah, I hope you got the idea how it's done. And yeah, it started training. It's going to take a lot of time, 38 hours. It's training on CPU. But yeah, that's it for now. I hope you understood this, and if you have any comments or queries, you can comment below. Until then, keep learning and keep exploring neurons, and take care. Stay safe. Bye.